everyone. I'm Jonathan Brendefur, and I'm going to be talking about place value today. So I have a couple different things up here. I'm going to chat about some good and bad with some different modeling and talking about place value. And I want you to think about place value through the system. So starting with kindergarten, we begin with units of 1, units of 10, we build up to hundreds, then we get by upper grades, by 4th and 5th, we're dealing with decimals, we're dealing with fractions, and typically it's very problematic. Place value is, kids really struggle with place value ideas and operations by the time they hit middle school. It's one of the biggest topic areas. So we're going to try to talk about why that is, and then how do we help with that. So here I have a number, which is 111. So one of the questions I love asking kids is, if you think about the words, what are words composed of? Take a minute to think about that. Ask that to kids, and a lot of times they will say letters. Sometimes it's vowels, consonants, things like that. But yes, words are composed of letters. What are numbers composed of? That is not common. So what do you think it is? A lot of people say, oh, numbers are composed with other numbers. Smaller numbers are actually composed of digits. So just like letters compose words, digits compose numbers. How many letters are there in our alphabet? 26. How many digits are there to compose all of our numbers? The digits that we have, many kids will list off 1, 2, 3, 4 is a digit, 5 is a digit, 6, 7, 8, 9. A lot of them will say 10. Well, 10 is a number, and it's composed of 2 digits, a 1 and a 0, which means we're missing the 0 here. So there are 10 different digits that make up our number. But in this case, this number 111 is composed of 3 digits that are all the same. They're all 1. But they, because of where they're located, place value, their place, they have a different value or worth. So we're going to talk about that for a minute. So each one of these, it's important to think about, if this is the unit of 1, then for our base 10 system, that's the unit of 1. And in our system, we'll say, yep, so we have the 1s digit, and then moving to the left is going to be the 10s. So this is going to be a unit of 10, but that is 10 units of 1, or 10 times larger, which gives us our 10. So being able to understand that we have a unit of 1 and a unit of 10, and they are a different length, but they're related to each other. Then we move over here, we have the hundreds, and right here we have a unit which is 100. That is 10 of these. I didn't leave myself space. I'll actually come back here because that's really about 10. And that's going to iterate 10, 20, 30, 40. That's going to continue to be a very large unit. And it's going to extend off. That's going to be our unit of 100. A lot of teachers will have a centimeter cube, and then a decimeter rod, and then a meter would represent that 100. And it's good for students to kind of see that relationship of a unit of 1, unit of 10, unit 100. You can actually talk about their relationships. How many units of 10 are in 100? There are 10 units of 10 in 100. How many units of 1 are in 100? There are 100 of these. A nice exercise for kids is to be able to say, if you take a step, they take 1 step, that's 1. Okay, so then what would 10 steps be? They walk off 10. So that's how far 10 is. Come back, and then they go into a hallway or be outside, walk 100. So they get a sense of what is 1, what is 10 steps, what is 100 steps. And that gets that idea of relationships. Now, a lot of times we'll see this type of model in classrooms that say, well, this is a 100, a 110, and 100. But this doesn't show that proportional relationship. So when you initially are building proportion, you want to be able to kind of show that relationship. In addition, once we hit decimals, the decimal place doesn't have its own place here. The decimal will just be right there, and then the next place will be the tenths. Now what happens is each of these are 10 times larger, or if we reverse that, each of these are 10 times smaller. And if you want to see a good rule of 10, Sam did a great job of a video on that. You can go watch that. So this is going to be 10 times smaller. So a tenth is 1/10 of this. So a tenth would be just a little here, and that's represented by the decimal and a unit of 1 here. So in this case, I could add decimal, and what the decimal is saying is that it is going to be a power of 10, 10 times smaller than the unit of 1, or 100 times, or 1,000 times. And it'll continue in that fashion. So being able to understand and see the relationship of the different digits, their relationship to the place value, how much they're worth, and their proportional size is critical to begin that journey of what place value is. Hopefully that was helpful, and we'll stay tuned. We'll have a few more videos on place value.